this video, I'd like to show you how you can use the central limit theorem and the TI84 to solve this problem. So suppose the average time spent exercising per day in minutes for all OSU students has a mean of 28 and a standard deviation of 19. This means that the mean is equal to 28 minutes and the standard deviation is equal to 19 minutes. What is the probability that a sample mean from a sample of size 150 would exceed 30 minutes? So here's the deal, is that now we're talking about a sample mean from a sample size of 150, which means that we no longer are talking about the population distribution. We're talking about the distribution of sample means. So for a sample size of 150, that means that the mean of our sampling distribution is still going to be equal to mu. This is equal to 28 by the central limit theorem. But our standard deviation, or sometimes called the standard error, sigma x bar, will be equal to 19 over my sample size of 150, which in this case is equal to 1.55. So now this is my standard deviation for my sampling distribution of x bar. So to rephrase this, x bar has a mean of 28 and a standard deviation of 1.55. Now if we want to find the probability that x bar is greater than 30, we can simply just either find the z-score for this, or when we're using the TI84, we just use the inverse norm command. So we can go to second, distribution, scroll down to normal CDF, and here we want to put in our lower bound, that'll be 30. The upper bound will be infinity. Again, this is 1 second EE to the 99. That'll be a really big value. Our mean is 28, and then the standard deviation is not 19. That's the standard deviation of the population. The standard deviation of x bar is 19 over the square root of 150, our sample size, which is 1.55. Enter in this, press enter, and we get a value of 0.0985.